Enthalpy changes can be determined directly or indirectly. Now that's making me think Hess's law. A student investigation, the reaction between magnesium and dilute hydrochloric acid. Please read the question and look at the equation carefully. So we've got 1 mole of magnesium reacting with 2 moles of HCl to form 1 mole of magnesium chloride and hydrogen. The student determines the enthalpy change for this reaction. In her experiment, she's reacted a certain amount of magnesium with an amount 50 centimetres cubed of 2 molar HCl, and the HCl is in excess. And there's a solution change, temperature change of the solution here. Now, because it's giving you temperature change, and also this here, we've got to use Q equals MC delta T. And this candidate here has used 12.8 times 50 times 4.18. So the 50 is the mass. I'm just going to get a different colour here. Some people don't use this correct mass. Some people have used the mass of magnesium. It has to be the mass of the solution. And 4.18 is coming from C, and 12.8 is coming from the temperature. Now, I've seen a couple of mistakes. Some people haven't been subtracting the temperature correctly, and they've been rounding up and rounding down, which there's no need for at this stage. So mistakes that are easily made is the wrong mass. So mass and temperature calculation. So I've seen those. Q equals MC delta T, and this candidate has got 2.68 as their answer. Remember, it's in kilojoules, not joules, which is another mistake that I've seen people make. So this candidate got 2 marks. Now, it says calculate the amount in moles of magnesium used by the student. Again, I would recommend, even if you're really, really confident, to put mass equals Mr. Mole, or your triangle, or whatever you've remembered to calculate mole. So here we've got the mass of magnesium divided by the MR to give them 0.02, which is mole. Therefore, this candidate successfully gained 1 mark. Now, the next one, calculate the enthalpy change of reaction, give your answer to 3 significant figures. This candidate here starred it. I'm assuming that means that this person didn't get it, but wanted to highlight that they didn't get it, which is a good thing to do in practice anyway. So it is the answer to 1, which is kilojoules, so that's the amount of energy being released, and then 2 is the amount of moles. Now there's a mark available just for putting a minus sign, and the minus sign means that it's exothermic. Again, how do you know that? Well, the temperature change has increased, release in heat surroundings, so we've got a negative, that's equal to 1 mark. And then if the candidate did answer I divided by answer II, they've got 2 marks. So it would have been 2.68 divided by 0.02. So that's that one there. Next, we're coming on to this one. So, student wants to determine the enthalpy change formation of calcium carbonate. What is meant by the standard enthalpy change of formation? Now, I gave this candidate a mark because they gave standard conditions. To get 3 marks, a lot of people did this. Some people obviously didn't, but a lot of people got this right. So 1 mark for saying that it's when 1 mole of substance is formed by constituent elements under standard conditions. Make sure you know that's 3 marks. B, part 2, using the following data and enthalpy cycle, fill in the boxes of the enthalpy cycle with the correct enthalpy change values, fill in the enthalpy change formation. So, here we've got a table. This candidate was able to gain 1 mark by getting 2 boxes correct. If he got 3 boxes correct, it was equal to 2 marks, and if it got 3 boxes it equal a mark, 4 boxes equal 2 marks, and the right answer equal 3. So, -168 is when solid calcium plus HCl gives you calcium chloride and hydrogen. So you can see here the products are the reactants in this equation, therefore that's 168. Next, I'm going to get some green to highlight this. Next, we've got the reactants calcium chloride plus H2O, and we can see that H2O is being formed in this one here. So that's why it's -285. The next one, this equation, I'm going to get a different colour now, back to pinky red. We have got calcium chloride and water and carbon and oxygen forming calcium chloride, H2O and CO2. Now the enthalpy change of formation for CO2 is -393, so here should have been -393, which is this one here. And then the other arrow, I'm going to get a different colour. Hopefully this will go up. So we've got calcium carbonate plus 2 HCl going to form calcium chloride and water and CO2, which is this one here. So if you match the reactants with the products, it's -5,4. Now what you need to do is add the arrows in the right way. I'm going to use black this time. So what we want to find is this arrow here by using this arrow, this arrow, this arrow and this arrow. So if we're going from Leeds to Bradford, A to B, and if I just label the arrows just for explaining's sake, 1, 2, 3, 4, then the delta HF, so enthalpy change of formation equals arrow 1 plus arrow 2 plus arrow 3 minus arrow 4, because 4 is going against the arrow, against the grain, and we want to find the direct method using this indirect method, which takes 4 reactions to get there. So it would be plus this, which is a negative value, 168, plus negative 285, plus negative 393. Now it would be minus 54. If you type that into calculator, you should get a value which should get you 3 marks. So pop that in your calculator.